All right. For those on your line, can you just give us a thumbs up that you can hear us? Oh, there's a mouse. Yeah, you're good? Okay, perfect. Thank you. All right, welcome everyone. Thank you for joining us in person and online. We've been doing this series on agents, part one, part two, part three, and we got inspired by the Doom series, part one, part two, part three. Now we're part four, so I don't know. Doom has to catch up with us. But thank you all for joining us. Just tap it. Oh, tap it. There you go. So I'm George Zotto, one of the founders and co-organizers of Deep Learning Adventures with David here and Robert. Thank you for having us. Thank you for being here, and thank you to Will and Excel for having us. We're part of a larger data community DC group, which the goal is to share information, share insights, educate us on the latest and greatest on technology. These are some of the meetups that we're part of. So we have data science, database, data wranglers, generative AI, DLAR, Deep Learning Adventures, some statistics, and other meetups, and some other ones. So if you have any interest in any of these topics, feel free to join us. We have some new sponsors. So thank you, Neo4j, Arlington Economic Development, Prefect, and Excel for space, food, marketing, money, Bitcoin, tokens, GPUs, anything you give us, we'll take it. Thank you so much. And tacos as well. We appreciate it. So this is the Slack for data community C if you want to join. And then Will and team do a great job there of sharing the newsletters. So if you want to catch the latest on newsletters, all the meetups combined, you can find them there. So with that said, we're going to switch gears now to a session on custom applications. We started this journey a while ago on Llama Index. Today, three of us are going to present custom, very different applications using agents. So kick it over to David.
All right, I'm going to say welcome to everybody again, both online and in person. I asked George and Robert to remind me to repeat any questions, but you are free to ask questions whenever they come up. So as you know, we're talking about agents. So I thought this article that I came across at TechCrunch was very appropriate. No one knows what the blank AI agent is. And the article is basically saying that every vendor has a different definition of an agent. A lot of them intermingle AI assistants and AI agents. For my purposes today, I'm going to define an agent as something that uses tools and has instructions on how to use those tools. And the something is an LLM. So it's a large language model that's using those. So as George mentioned, this is a continuation of our generative AI series, which we do have on YouTube. We record them all. We'll post this one probably tomorrow. But in relation to this one, if you want to go back and see how this is built, we started off, I gave an introduction here of how to build and evaluate a Llama Index RAG system, just as a foundation for this. And then in part one and part three of this, how's it do skin here? Okay. In part one and part three, part two, we went through building a JavaScript version of RAG with Llama Index. Part two, we began talking about agents, and we built an agentic RAG with Llama Index using Python. And that's the approach I'll take today. And part three, we looked at the particular use of workflows with agents. And that was the last one we covered in our last meeting. So today we're going to talk about some agents. And in the meetup, I've got the link to this particular notebook that I'm going to go through today. So feel free to look at it. It's on GitHub, and anybody can take it and experiment with it. There's some prerequisites here in terms of things you need to install. Index, of course, is the framework we're going to use for agents and RAG. There's an experimental part of this that I'm going to use, and I'll point out what particular package is experimental. And then there's all these imports. And because I'm on collab, I wanted to make sure that the versions were the same. So I put a few asserts in here to make sure they didn't update on me. And I've run this ahead of time. The first thing we're going to do is choose our large language model. In this case, I'm going to use OpenAI, but LlamaIndex supports many different large language models. But if you are using OpenAI, you need to bring in your API key there. And I'm going to set this to be using GPT 3.5 Turbo. And I want very little creativity from the model in this case, so I'm going to set my temperature to 0. For the data that our model is going to use, our agent's going to use, in fact, we're going to look at what's called the capital byte share data. And this is kind of inspired by a previous session that Robert did, where he did a deep dive into their data. And you can go to our YouTube link there and watch that session if you want to know more about the particular data and some of the analysis that he did on that. So there's the site for capital byte share. And they have the data out available on S3 for you to download. I downloaded the January of this year bike share trip data, so all the trips that users of the bike share did. So we go and get that. It's a zip file, and once you unzip it, you get a CSV file with this type of data inside it. Now, this is a lot more than I need, but it's got every ride that happened in January. It's in particular, it's got where it started at, where it ended at in terms of the start station names, the end station names, and most importantly, the latitude and longitude for those start and stop points of the rides. Do it, zoom out a little bit. Okay. A little better? Everybody see in the back? Okay. How about that? Pretty good. Okay. So one of the things here is I don't need to know about every ride that happened. In particular, I'm not interested in e-bike rides, which start in random locations. I want just the rides that happen from station point to station point. So I'm eliminating any values or any rows where the start station or end station is not available, is null. And there's other rows in there that I don't care about, such as the ride ID, the type. I don't want to know the times when this started or ended. And I'm not even really sure what the member casual. It's probably levels of membership between the different subscriptions they have. Once you do that, you get some duplicates. So at the end of this, I drop duplicates. And you see I'm down still to 49,000 rows of data. What I'm trying to do is pick out just the locations of their stations. They may have this in another file somewhere, but I couldn't find it. So that's why I started with this bigger collection of all their rides. But I'm trying to pick out just the stations and their locations. And so what I'm checking here is just to make sure that all the start stations have all the end stations and that all the end stations are listed in the start station list. So that I make sure I'm getting every single one of the unique station locations. And then I'll start to do a little bit of cleaning. I ran into some of the stations that had spaces on the end or at the start. And that was kind of just when I was playing with it, I found that annoying. So just clean that up. And then I want to reduce to the minimum amount of station data that I need for this exercise. And the things I'm going to capture are just dealing with the start station. So I no longer need the end stations since I know everything is the same between them. And for convenience, I'm going to rename some of those columns just to a station name, station ID, the start latitude to just latitude, and the longitude to just longitude. And I'll drop any duplicates again that I have there. And the station ID, I just converted that to an integer. So this is my data that I end up with. They do have quite a large network of bike stations, over 9,000 in their area here. And for each one, I've got the station name, the ID, and the latitude and longitude. Now, pretend this is our private data. So I got it from a public source, but I'm going to make it private, and I'm going to add in a very special station. I'm going to give you an idea of which one I'm adding in. Let's get this up. Oh, okay. So special it's invisible. Let's see if I can get the word. Here it comes. Okay. Well, probably let that load. Um, so I'm adding a station in there that I call the DLA station. Here we go. It's going to be in the center of the NIH campus. And some so yeah. So right here, you can see it has two stations on either side of it. I'm going to put a station right in the dead center of it, and I'm going to call that the Deep Learning Adventure Station, or DLA station for ease. And I'm going to also be interested in the station that's north of here. If I can get there. Oh, right in here, I believe. Yeah. So this is the Rockville Pike and Rose Avenue station. If you've ever heard of shops and things and restaurants called Pike and Rose along Rockville Pike. This is the closest station to that. So looking back at our, sorry, let's go back to our. Okay. So here's where I'm adding that station to our database. I'm going to get a name of DLA, a random ID, and the latitude and longitude there I got off of a mapping application. It's right in the middle of NIH. So I'm going to convert this data into GeoPandas, and you'll see why in a while. We actually did a session, a Kaggle learning session on GeoPandas a while back. If you're interested in that, it just allows a normal data frame to be converted to a GeoPandas data frame that has some particular things around geometry and some of the calculations you can do around that. So to do that, I'm going to convert all of the latitude and longitude data to what are called points in GeoPanda. And that can be a type of geometry that we're going to use. So the important thing here is that the points require the longitude to be first. So just make sure you get that in order. And with that, I can form a geo data frame instead of a regular pandas data frame, where I have my data that I had before, as well as this geometry added in. And then for projection on a map, you choose a type of projection, and that's what this CRS is here. Now that I have these geometries in there that have these points with latitude, longitude, I don't need those anymore, so I'm going to drop those out. It has a sample of that GeoPandas data where we've got the station name, still have the station ID, but now we've got geometry in there as one of our columns.
Nerdiness. What does the CRS stand for, and which type of projection?
Yeah, coordinate reference system.
And which type of projection did they choose?
This one right here, this EPSG 4326, and don't ask me the details of which one it is. It's a common one to choose, but there are reasons to choose depending on how you want to display things. That's one choice, but also some things work better for calculating distances between points and things like that. So there's a reason for making different choices. Good question. So the question, I don't know if people heard, but the question was, why did I choose the CRS of EPSG? It's a common one that's chosen that I think it's the default, and I just wanted to show that that's the one I'm using. So here's the problem I'm trying to have my agent solve, or the task I'm having to do, wanted to do. And I thought the first thing I would do is just ask a chatbot to do it all on its own. I'm not going to give it any tools. I'm not going to make an agent. I'm not going to tell it about my RAG database. I'm just going to ask it the question and see how it does, right? So here it is. I want to find a route using Cabby to start at the closest station to Pike and Rose and ending at the closest station to 10 Center Drive, Bethesda. And that address happens to be at the dead center of NIH in Bethesda. So I asked it to create that for me. And here's, again, I'm using GPT 3.5, so the same model. And here's the output. So it gives me, it says start at the Pike and Rose Cabby station, which I believe is an older name for the one that I showed you, which was Rockville Pike and Rose or something similar to that. So I think it's the same station. It may not be. The address looks a little different, but it's close to there. So it did pretty well. And then it gave me, turn by turn directions on how to get to the Wisconsin Cabby station, which is the one that was to the right of NIH along Wisconsin Avenue. It says it's approximately 2 miles, which I don't think is right. I believe that it actually is much smaller than it should be. And I have no idea if it takes 15 or 20 minutes because I haven't ridden it myself. But it did pretty well. Not bad. Let's try it with an agent. So the first thing we do is we're gonna need some tools to do this. We just proved that the LLM can't do this by itself, right? So we're gonna need some tools. We're gonna need a mapping tool to find a location or where you want to start at, given an address, and where you would end at. We need to build a tool that can get the closest bike share station to those 2 locations. And we're going to build this with GeoPandas because that's the way our data is, right? So first thing we're going to do is we're going to build a tool that allows us to get a latitude and longitude given any address, okay? So for that, I'm going to use a library called Nominatum. It's an open source geocoding tool that uses OpenStreetMap data, if you're familiar with OpenStreetMap. So you just have to have a key and you can use it. And we're going to give it a user agent of DLA app, and we're going to use this geolocator technique. So the first thing we do is define this function. We need to go, given an address, I'm going to print out the answer it gives, the location, just to show us. But all I'm really interested in getting back is the latitude and longitude for that location, right? So I'm going to give it a test address of 1600 Pennsylvania Avenue. I'm going to call this function just to see if this works. And I'm testing here with an assert that it gives me back this latitude and longitude, which is correct for that address. And then I'm going to use that function in a function tool, which George introduced us to some of these last time, where we call the function, or we give it the function get lat long. It has a name of get location, and then a description, which is pretty important for your LLM to know how to use this tool properly, right? So I'm telling it this tool gets a latitude and longitude of a location given an address, right? It turned out when I printed that location above, when I tested it, the White House actually is at that location. So it knows where it's looking, right? So it gives the complete address here, but it also captures the lat long. What's that?
On your description, did you ever play with different? You could describe it as given a location, return lat long, or
yeah, you can give it lots of different descriptions. It's purely, and some will work and some won't.
So yeah, I guess my question is that did you play with the description at all to figure out which one sort of pattern?
And this time I had done a lot of things like this before, so I knew kind of what to give it. But you would need to do that because this is almost like prompting your LLM on how to use the tool, right?
Right.
So you need to work on the more elaborate your description, the better it's going to do, in my opinion, in my experience. So let's test that tool. We tested the method, but let's test the tool. And the way we're going to test that tool is I'm just going to create a spare little test agent here. It's an OpenAI agent. it's given that location tool, and I set the verbose to true, so it's going to give us some output. So I'm going to chat with it. I'm going to ask it, what is the latitude again of that address? I'm going to tell it to respond with a JSON object, because that way I can write my assert against that object. Otherwise, it's going to talk to me like I'm a human. It's going to give a sentence instead of giving me just the value that I want. So asking it to give a JSON object is one way that you might be able to get it to give you only the numerical value. So do that, I assert for back to this 3889, which we saw up here, is the correct latitude for the White House.
Does it ever disobey you and not respond with a JSON object?
Occasionally it does. This is not the best way, and
Yeah.
because they're very good questions. So the question does this sometimes not respond with a JSON object? And the answer is yes. And then sometimes it responds with a JSON object that contains much more than the numerical value. So it's a good point, and it's something that we're going to address a little bit later in here. Again, I'm just testing you to get the longitude right. Happens that it does. Here you can see the verbose output as it was working this. So it got my message of what I wanted. It called my get location tool with the address that it's given there, and the output was this White House that it figured out, and it also had the latitude and longitude, which is what it was supposed to give me. Note that it only called this once, even though I called it twice. It's because it remembers, I'm in a chat function with it. It remembers that it already got the longitude in the prior question. So it already had that information. So it didn't go back to the tool again. It just used what it had, right?
Good question.
Yes.
I got a little lost. What happened to the bike share data?
I haven't got that. I'm building tools that'll get me toward that.
Okay, and when you put in your new middle of NIH campus location.
Yeah.
Did you create a longitude and a latitude for that location?
I did. So I gave it a name and the latitude and longitude. I looked on Google Maps and just put a pin there and checked what it is. Yeah. So the question for those online was, have we really started using our RAG data? Where did it go? We're building up to that. We haven't used it yet. And then the other idea was, how did I get my latitude longitude for the special DLA station? And that was just by going to Google Maps and checking, click on it. All right, so we've gotten a tool now that will give us a latitude and longitude given any street address. But now we need to go back and look at how do we query that RAG data, right? That data that has our, and it's not even RAG really. I could put this into a vector database, but I'm just going to use it straight as a data frame for simplicity here, right? So this could be your company's data in a vector database that's stored. But for simplicity, I'm just pulling it right into I'm going to deal straight with our GeoPandas data frame. So this is where I'm going to use the experimental package that I talked about earlier. The Pandas query engine is experimental and probably will be adopted into the main packages. It really works well. So you can look at it and I'll show you some of the documentation on it in a minute. But this query engine, I can query the LLMs behind there, but it knows how to use a Pandas database or data frame. And so the first thing I want to ask you is, what is the geometry? If you recall, our data is now in geometry, so it's no longer in just plain lat long. So what is the geometry of Oakleaf and Lockwood Station? So the actual query engine forms this into a Pandas statement. And you see here, it's looking for this in the data. And so this is if you were to form your own, use your own Pandas Python commands to do this. It's doing it for you behind the scenes, and it gets this output of 7699 and 3903 for longitude and latitude. If I went and look in there on my own, I can see that this is the row that it picked out, and indeed it's the correct row and the correct latitude and longitude.
don't want to slow you down, but if you misspell oak leaf and Lockwood, or you ask it in sort of a silly way, does it still get the answer?
I don't think, so the question is if, say you spelled Lockwood with one O or something, incorrect, would it do a kind of a fuzzy logic match to find it? And I believe the answer is no. It's really running it just like if you were creating a pandas data frame on your own through Python. So it's exact. I haven't tried it, but I'm pretty sure that's what it's doing. Because it's showing you the panda instructions running behind the scene there. And so I want to know, can it also just pick out, like last time I asked it for geometry, can it pick out just the latitude itself, right? So here it goes and it does, you can say it does kind of behind the scenes, this I load 0 to get the geometry, and then getting the Y, because the X is the longitude, the Y is the latitude, so it pulls out the latitude correctly. So here's the actual value there. So well, I'm going to do something more sophisticated. So I'm going to ask it this time to calculate where's the nearest station if I give it a latitude and longitude. The answer is no, though I'm going to go through, it does pretty well. It actually does pretty well. So it starts to do what you think it would do. It looks through all of them, all the points, and it calculates, for each of them, it tries to calculate a distance, and then find the minimum based on this station location. Unfortunately, it doesn't really understand behind the scenes how to do that with a point. So it's, this pandas craze is built for pandas. It's not built for geo pandas. So that's where we ran into a problem, is the fact that these are points, they're geometry instead of just a latitude and longitude. If I had left it as a latitude and longitude, I bet this would have been fine. I was going to show you at this point that this query engine has the ability for you to go in, like everything in Long Index, and customize it to your own needs. So you could change the prompt template being used by the pandas query engine behind the scene, and I'm guessing I could write a prompt template for it that it would use to do that distance calculation for me correctly. So I could do it all with just the pandas query engine, probably. But I'm not going to do that. I'm going to build a tool to use GeoPandas to find that nearest station, given a latitude and longitude. All right. So, and I'm going to be doing that. When I say the nearest station, I mean the nearest point in our data. So, because we're using geometries that are points. So, given a latitude and longitude, I have this function. It turns the target point that I'm looking at into a point that it can work with. Again, the longitude comes first, and then using the methods in GeoPandas, I can just find the distance for that target point for every in my data. I can define this distance column, and then I can use this, IDX index min to find the smallest value, right? And from that nearest point, which is a point, it's a geometry. I want to get the station ID. It's really the nearest. But I want to get the station ID and the name back. That's what I'm interested in getting back. So I ran a search on here. This happens to be very close to the location of the Oak Leaf and Lockwood station we looked at before. So that's the road. That's what we get back. And I'm going to build a tool. And again, I need to give it a good description. It says get the nearest station, giving a latitude and longitude as input. Okay. So that's another one of my tools I'm going to use. I have not seen much difference in the name. I know that when George was presenting, I think that during their discussion of this, building these tools, these function tools, but the name did make a difference. So I have not played with that a lot. I find if I can get everything in the description I need, as long as it has a unique name, it seems to work.
You mean the tool name?
The tool name given here, yeah.
Yeah.
That's, so the question was, does the tool name make a big difference in how well this does?
Just an ID.
I think it might be more than that, based on what George saw in the short deep learning course where they went over this. I just haven't. I found that the description gets me everything I need, so that's what I usually.
For context, if your logic doesn't do what the description says, it's up to you. The LLM has no idea what you're doing. So if you're getting the nearest latitude, longitude as in your station. But if you do something else, the LLM is not going to check your logic.
Right. So another tool that I mentioned that we're going to need is given the lat long, or to get the latitude and longitude given a station name. So here I'm just going to use this. We've given the station name and output of the latitude and longitude. And all I do there is I use this Pandas query engine. We saw when we were testing it that it could do this, given a station name, you could give me the latitude and longitude. So I want to use that. I call that the station location tool. Again, the description is pretty straightforward. Give me the latitude and longitude station via the station name. And the last one was the one that I tried to do Pandas and it couldn't do on its own, but it was to get the distance between two locations given lat and longs. So this is that. It uses a tool from Geodesic, where does that come from? It comes from GeoPy. So sorry, I have the link down here for you. Yeah. So if you want to know more about how that is calculated, but it's using GeoPy to do it. And when you do that, you have an option of what units you want to have the distance out in. I'm just doing miles for us right now. So this distance tool, all it does is get the distance in miles given the latitude and longitude of two different locations. All right. So I'm going to create another simple test agent, and I'm going to give it these three new tools that we created. And let's do a test here. Let's ask it, what's the latitude of the station name Fort Stanton Rec Center? So here's what it does. The first function it calls is that get station location, which is going to give us back the latitude and longitude given the name of the station, right? So here's the output it gives us. It actually goes and runs two different Panda functions to get first the latitude and the second one the longitude, and then combines them in the response to us. So here's the response back that it gives us. And I asked just for the latitude, but it went and got the longitude as well. Probably didn't need to do that. Maybe there's a way you could write the prompt to control it a little better. But the thing to note here is it gave me a sentence describing what the latitude, just like a person might talk and give me that, right? So I'm going to need eventually to only get the values back. And here I was just checking that, and you can see it agrees for the. I'm sorry, no, this is for the next one. So I wanted to do another test here to see the Southern Avenue station, where the latitude of that is. So I'm going to give it a very close location to there and say, what is the ID and name of the nearest station to this latitude and longitude? And it goes through and calls the nearest station tool with these arguments of latitude and longitude, and it gives me back Southern Avenue as well as the ID. So again, it responds back to me in textual form. It tells me that, the answer as well as the ID there, as well as repeating back what the latitude and longitude are, which I didn't ask for. But now I'm going to test my distance tool. I give it two station names and ask them what the distance between them is. And these are quite far apart. This would be a good little bike ride if you could do this one. But so the first one it goes after is Southern Avenue Metro, and it gets the latitude and longitude for that. Next, it calls and gets the Jones Branch and West Branch Drive location for that station. And then it calls my distance tool function. So for that, it needs the latitude and longitude of the first station and latitude of the second station, and it gets back 14.5 miles, which is about correct. Not, excuse me, not as you would ride a bike, but straight line. Important note. I'm sure it takes a lot longer than that to ride. And when I look at the actual response, you can see it gives me a nice sentence here, and it actually rounds the miles to 14.60.
How did it know to call, you know, your distance tool? Did it do that on its own? It just learned that, or did you need that instruction somehow?
So when good question, yeah. I'll go back up here where I put my test agent. So the question was, how did the agent know to use that tool to get, for instance, like the distance, to use it to calculate the distance? How come it didn't just do it on its own and all that? When I built this OpenAI agent from tools, I gave it, first of all, I gave it all of these tools for it to use. It probably, in this case, my descriptions are pretty good also of these tools. So it looks at the descriptions of these tools and what they're capable of doing, and it has instructions built into it to call the correct tool. It may not always do it. So there are times when it will skip your tool and try to do it from its training data, right? In this case, it doesn't have something like the distance between two cavity stations, probably in the training
So
data.
that's in the model, in the ChatGPT model.
It's in the Llama index
Okay.
framework for the functions for how they built this agent, right?
Thank you.
But there are times when you're asking it a more common question, which it probably has training data about, and it will ignore your tool. So sometimes you have to, in your prompt to the model, make sure you specify use tools, use this tool to do this certain thing. You've really got to wrangle it in sometimes. Yeah.
Don't use the training data.
Don't use, yeah, sometimes you have to tell us explicitly, don't use your training data or your original context.
The function name,
Yes.
function name helps it, right? The function name, I missed the function name of.
Or the distance tool?
Yeah, like the tool, like the station location to distance to nearest station to, these are all functions. If I change the function name, does it mess up with it?
So the question was, if I change for these function tools, if I change the actual name of the function, does it mess it up? I suspect this is just kind of like a pointer to the function, and it doesn't even really look at that. It uses this name variable here. It does gain knowledge from that in terms of what this function does, and it really uses this description. So these two things, I could have called this probably, get lollipops, and it probably still would have worked, right? So
Because the name and description and.
yeah, these variables, the name and description, are really important for the language model to know how to. Question? Yeah. Yes.
It needed three tools for that, right?
So the way I formed it was, I said, yeah, this one, right? So I said, what is the distance? But if you notice, I had already asked it some questions about these two stations.
You give the same station that you.
Yeah, yeah. So it Southern Avenue Metro was new to it. You can see it called that one, right? Did it call the other one? No, it did call both of them. Yeah. So it called all the tools because these were not in its memory.
That in first needs to get first Latin long, second Latin long, and then call it the business. And how
That's an excellent question. So the question was, in this one, where I asked it to call to get the distance between Southern Avenue Metro Station and the station Jones Branch and West Branch. How did it know the order to call the tools? And that's a really good question. The answer is it knows the inputs that it needs for each tool. And if it was to try to call the distance tool right off the bat, for example, it doesn't have the inputs yet for it. So I have not looked at the way this OpenAI agent is built, but I suspect it's smart enough to know if I don't have the inputs that I need for one tool, I probably have to look at the other tools prior to that.
Probably not something that the LLM just kind of figures out based on what it has.
Yeah, and what it needs to be able to so you've given instructions about how to call the tools and what it needs as input. And it knows if it doesn't have that input, it can't call that tool.
So if you scroll up your definition, yeah, right, then, so description is one thing, but also the function, signature, so get distance, you have to get distance somewhere.
Yeah.
So it expects
Right.
four inputs, right?
So it's a very good point by George. When you build your tools, these are function tools and they're always calling a function. These functions, you have to be very explicit about the types of inputs that you need. It's a requirement. So it's the way it's based.
So the FN, sorry for a question for the uninitiated.
That's all
The
right.
FN is something you write. This is your function.
Yeah. So get distance here is what I wrote,
Oh, okay.
right? And then the default for these function tools is that it has to call one of your functions, and you always have to give it a name and a description to go with that. But for these functions to be allowed here, they have to have the types of inputs and outputs as well given in the function definition. Yes.
So out of curiosity, with the name variable and you've got this string value distance, if you gave it like a 2 or 3 word name that had underscores, does it know how to handle?
The underscores?
Yeah.
I think so, because when George was talking, what's his name? Chu, the guy who wrote Llama Index originally, when he was discussing it, he talked about the model can get information out of that. So I imagine it can parse that. Yeah.
Maybe we should try and break this thing. Find different names and
Mix it up. Yeah.
Oh, possibly. I think for me, the description and the signature are key.
Right.
Those are not right.
Excuse me.
The names I can.
All right. So
Oh, at this point, you've loaded in the bike share data.
I have a tool that accesses it, right?
Is accessing.
And that's how it's finding out the locations for the stations. The primary thing is the station names, IDs, and the locations. So whenever it needs to do a calculation based on a specific station location, it's using that data.
Got
So one thing you notice with all these responses from the model is that it's talking to me in a natural language. And for me to put this actually in pseudo production like code, I need to actually have it give me values back. Because what happens with language, first of all, I don't want to have to parse it to find the distance here, right? The other thing is, you run this over and over, even though it's temperature 0, it's going to change the way it responds to you. It's never going to respond the same way. So dealing with that would be a real nightmare. So one of the ways that you can approach this, and there are many, and as I talked about George last time, there's companies that build their whole company on how to deal with the output from large language models. But one of the ones that you can do is you can have the language model working with an object, and you're building up specific parameters, variables inside of that object. And so I'm going to build a route class, which represents a route on the bike share. And I'm going to give it the large language model some tools for working with a route. I'm also going to have a collection of these routes that I can build up. The collection of routes, in this case, think of it as this is my actual reservation system. So things that are put in the routes are actually reserved rentals of a bike share, or it's like you book one. It's the real thing. If you see an object in there, it's finalized. Okay. But it has a start state, the IDs for those, and then the locations in terms of latitude and longitude for that, as well as the distance between the start and stop station. Okay, so that's my route class. I'm going to define a function called create route, which requires me to give it these values: the start station information, and the end station information. Note that I'm not giving it the latitude and longitude here, but just the names. And when I do that, I create a key in my route table based on the station ID of the start and the end, and I put a 2 in between them. So that's a unique identifier for this particular route. You would need more than this because obviously multiple people could book the same route. So your key would need to be
Start and start.
yeah, yep, yeah. So it's just telling me it could be a random number. It doesn't really matter. It's just telling me this is where I started and this is where I see what you're doing. That should have been stop station ID on the you're right. Found the first bug. Doesn't impact this because it doesn't, we'll see it doesn't matter, but it would in real life, definitely. And then when you create the route, the way you put in these, now that you have your key, you create this route with that key, and you can add in your values. Okay. We return back from this the route and the key that was created. Okay, so returning back the key from this is key, or is important. I also have something to be able to update a route. So you noticed I didn't set the distance or anything. So for instance, I could use this update function to update the distance given the key, the property that I'm updating, which will be distance, and then the value, which is a float number of miles or whatever. So, and it just returns back again a string that tells me it's been updated. And I have another routine that allows me to check the state of this route. Basically, it pulls it out of the routes table and tells me what's going on there. All right. So each of these functions is going to be used in a function tool that the model will be, the LLM will use. They're pretty straightforward. The first one says it creates a route object and adds it to the routes directory or dictionary, excuse me. The interesting thing, maybe it doesn't add it to the dictionary, but I wanted to show you some of the flexibility here. Note I also didn't tell you what it needs to create the route object. I didn't tell it any of the inputs or anything, right? It's going to have to look at the functions to figure out what it needs, right? So I was pretty abstract here with what's going on. The update tools, same thing, updates route object properties, and then the get route state, gets the properties given the key. All right, so now I'm going to build a real agent. This is not a test agent. So this agent is going to have a specific system prompt, and you can see it here. So you're in a misspelled assistant. I see that, but whatever. You're a helpful assistant who. This is a great thing about using LLMs is they're very tolerant of your language. That's the one thing they're good at. So anyway, you're a helpful assistant who is connected to this route system and helping with making a route, right? The route will have information about the stations and the distance between them. The user is going to provide you the starting address and the ending address. I didn't say a start station, just an address, right? And that's what you're going to need to do. So the first thing you're going to need to do is get the location, latitude and longitude for the starting address you're given, the latitude and longitude for the end address. Then you got to find, for each of these, you got to find the closest or the nearest stations for the end and starting addresses, right? And determine the distance between them. Okay. You're going to present that back to the user and confirm, is this acceptable? If the user accepts the route, then we're going to create a route object with all of this information that we've collected, right? So, and then I tell it to update, the last step is update the route object with the distance. So when I said create the route object, I didn't provide any distance information. And in fact, my create route object function, if you recall, didn't have that information. So it's going to have to calculate the distance to do that.
How flexible is it if you had like optional or default?
You an object. I haven't played with that, but I've actually, that's interested me quite a lot. Like, so it's, I think the two options, it's optional or required. So, yeah.
You don't have to do this for your DLA at NIH, right?
Well,
You had one.
so one of the tests I ran, so the question is, do I have an address for the special DLA station that I created in our pandas data set back in the beginning? And one of the questions I had asked when I was testing the get nearest station, given a latitude and longitude, was I gave it that location, latitude and longitude for that DLA station, right? And it gave me the two stations on the side of NIH, right? So I gave it the middle and I gave it the two. But when I asked here, when I asked the LLM on its own before I gave it any tools or an agent or anything, I asked it for a specific address. That address was the location of the DLA station.
Okay.
So I put the address that's the middle. I think it's like 10 Senator Drive, if I remember right. Yeah, that happens to be the dead center of NIH. Yeah. You just ignore the fact that you can't drive or ride a bike there. But there's some security problems. Yeah, our station might not pass the test. Okay, so from that prompt that I'm going to use, or the prefix message as they call it, I'm going to create my main agent here. Again, it's an OpenAI agent from tools, and I'm giving it all of these tools that I created. So the ones that have to do with locations and distance, as well as the ones that have to do with creating a route, updating a route, and all that, right? And here I put the prefix message in, which tells it, this is what I want you to do. This is the spec here. Okay. All right, let's ask it. Let's see if it can do the job. So the first thing we're going to do is, I want to find a route using Cabby between two addresses. Can you help me, please? So it looks at, that's what I'm trying to do, right? It adds that into its memory so it remembers it. And it says, of course I can assist you in finding the route between two addresses. Please provide me with the starting address and ending address of the route. So if you remember, that's one of the first two steps that it's already trying to acquire, right? So starting address, ending address of the route. So here I give it, I want to start at this Pike and Rose location and end at 10 Center Drive, which is the middle of NIH, right? And it says, okay, it adds that into its memory. First function it calls is get me a location given the address, right? So it gets the lat and long for the location of Pike and Rose. And it gives me the location for 10 Center Drive, lat and long for that one, okay? So it's got that. Now it wants to find, given those lat and longs that it just found from my address, it wants to find where is the nearest station to those addresses, right? Or to those locations. It finds that the Rockville Pike and Rose Avenue is the closest station to that, which is correct. And it finds the nearest station to the other lat and long is our special DLA station, right? And the last thing it does is it calculates the distance between those two locations. And it calls our distance tool to do that. And it gets 3.45 miles, which is much more realistic than the 2 miles that the model thought it was on its own a long time ago. So here's the response that comes back. Says the distance between the starting station, Rockville Pike and Rose Avenue, and the ending station, DLA, is approximately 3.46 miles. So it told us what the start and stop station, it's basically told us the route. Would you like to proceed with this route? So now it's querying us, right? Note that, do you think it's used the route object at this point? Remember I created that route class with all those things? No, it's just use my tools to respond to me, right? Right. So it's still responding, for instance, in text. It's still, interacting with natural language, right?
So is that going to learn that as a root now?
Well, the last thing in our prefix here, one of the last things is if,
Update the root object.
yeah, if the user accepts the route, then create a route object with that information, right? And that's what's going to happen. So, so here, I just wanted to check and show that the reservation has not been made. The dictionary of routes is empty at this point. There's nothing in there. But I tell it, yes, I like this route. Please create it. And so it calls my create route function with that information. And here's that error where the route has the weird name, start station twice. But for all intents and purposes, everything's working the way I designed it. Here's the response it told me back, successfully created that route. If you need more assistance, feel free to ask. But it did put it in the dictionary. Yes, it did. So here's now in the dictionary is my route. Any questions? Yes.
So is this, the reason it was able to put it in the object in a structured fashion is similar to like if you say, here's the example that I want you to follow when you output it.
That's another approach, yeah.
Is it using that same idea or is this more direct?
It's more direct. It's looking at that route class. I'll go back to it.
I suspect, David, under the hood, it is like in the framework somewhere, it's doing something like that, or it's showing it.
Well, so the route class is based off a base model, which is a llama index class. So it knows that it needs to find these particular types of objects, and so it's not just to give an example. I've told it very.
It's not Pydantic based model.
It is. In fact, this comes base model comes from Pydantic, I believe. Llama index Pydantic class. Yeah.
The llama index or.
Yeah, here it is. So it's right here. It's coming out of llama index, but it's probably based on the Pydantic. Yeah. So that was a question about is this base model from the Pydantic, Python Pydantic.
But because of that, it does actually, the llama index basically is wired to understand classes.
Yes. Because of the way I wrote it and told it what to do. What I find interesting is that when I create my agent, right? So I have this prefix messages, which I mentioned the route object, right? Right. But in my creation of my model, I don't mention a route object, but I do have these tools that know about the route object, right? And so I think that's how it knows. It's not that the model necessarily knows that by default, just because there's an object somewhere in this Python running here. It looks through here and then sees that it's Pydantic and does it, I believe. So, so there's a problem here. Just want to look closely at the actual end result of my route. So here is my route, right? So I've got my key. I got my station name, and you can see that the station name, the start ID is a number. I didn't need to have any locations in here. In fact, if you looked at my create route, I didn't ask it to save the locations. I could have had it update those or save it originally when it created, but I did ask it to update. So I did run this multiple times, and sometimes it would update the distance. It just wouldn't do it consistently. So I think that's where the workflow would really specify and make sure that happened. I mean, this is you're getting pretty workflowy when you're doing it. So. Any other questions?
Yeah. On step 8, why do you have it update the route object with the distance, and why not just instantiate it with the distance at step 7 when you create the object?
That's a good question. So the question is, why did I put in this extra step 8 to do the updating of the route object with the distance, because I wanted to show this issue. It would certainly work if I put it in the definition of create object to include the distance. It works every time. But I wanted to show that this updating, this many steps in updating is not consistent. Sometimes it works, sometimes it doesn't.
I wonder if you made step 8 something different and novel.
Yeah.
Right? So it's already got the distance calculated. In step 7,
Yeah.
when it's creating the route object, it's got a distance.
It already knows the calculated distance.
So then
But it-
you're saying update the object with the distance, but it's
Yeah.
already got that. So I wonder if that's confusing.
I probably could have referenced the distance that you calculated in step 5 or, something like that.
Well, I mean, I wonder if like if step 8 or something like add in a random color to this new, like have
Oh.
a new field that isn't calculated or something. I wonder if it would behave differently.
It might have done it. Yep. Any other questions? All right. You're going to turn it over to George. Oh, Will. So
Great session.
you're continuing this Zoom session. I can just.
Yeah, I can do that. Yeah, great.
You move that's all there.
That I do. Get the meetup. All right.
Sharing. Get out of your way.
Okay, let me get set up here. So, cool. All right, I think we're now sharing there. So let me go ahead and get set up on this now proper screen. And with Zoom, share my screen. Full desktop, perfect. Very good. Then get rid of the meeting controls and the hide this as well. Cool. Yeah. All right, got that almost out of the way. Cool. So, hi folks, I'm Will, and I'm going to show you a sort of rudimentary agent built using SQlite. Because I gotta say, Llama Index, it makes a lot of things really easy. But to a certain extent, you can think about agents and tasks independently from any of these frameworks. So I'm going to go ahead and launch my program here. And this is a fast API server that has a SQLite database in the background. And so we can give it a prompt. So tell me a joke. Why did the database go to therapy? Because it had a few disconnected issues. All right, it's maybe a better joke. Yeah. Retrieval issues. Oh, it's pretty good. It's pretty good. Yep. Now the thing that's fun here is doesn't seem very agentic. I'll give you that. If we actually go and look at the code, whoops, that's not the code. The code is there. So if you actually look at the code here, this add task function, which is, make this a little bit bigger for y'all. So we've got our main function, and we're asking for that input, enter prompt. And then the final thing, if there are a couple of things like exit, list tools, that kind of thing. And if none of those parse, then it adds that prompt as a task. And the fun thing here is this add task function is just 2 SQL queries. One is insert into the tasks table a record with that prompt as the goal. And then second, after that is committed, is to select the response from the tasks. So in this case, us typing that in goes to the database. The database then makes the call to the LLM and then puts it into the table. And then when that transaction is done, we, the Python process gets informed of that it can proceed, and then it proceeds to run that next query. So Python here in this case, well, technically it is actually making the call, but it's doing that because the database tells it to. So SQlite, as many of you should know, is a in-process database. So we are actually defining a chat function here. This is using Llama 3 8B, and we're actually registering it as a custom user-defined function in SQlite. And I've got some stuff to do here around getting it to like do iterations, selecting some tools, but we got a pretty fun proof of concept here.
So when there's a new row in the database, it triggers the prompt.
Correct. Yep. It's actually based on a trigger. Let me make this a little bigger. So this is the magic. So we've got a trigger, and when something new is inserted into the tasks table, we're setting it as the default in that like create task function as is active equals 1. We update it so that it's not active, and it sets the response column as this chat goal function. And this is that chat function that we registered. So it is then making that call to the Llama model that's hosted in the cloud. And then this is done as a transaction. So this either fails or succeeds. This is actually, I got to say, I don't recommend this if you want to build a performance system, because this is, it's an external HTTP API call. And as such, it's going to be, pretty fast, probably a few hundred milliseconds. But that means that the database is going to be fully locked up, and thus the application is going to be fully locked up for that. That said, you can use this with longer running tasks if you have a database that can support that. So this is potentially a way to have just like really easily add LLM calls to a database and basically turn your database into your actual like agent brain. It's also fun because we've got a table in there that has a list of tools. We can also do things like query the database. Got a good number of things. I was experimenting with getting it to pick a tool, but that was with a different prompt. So I've got it to the point where it can choose a tool. It's not hooked up to actually use them yet, but pretty close. You can also see I had some more environment issues with the tokens not showing or the auth token not being passed correctly. But, yeah, whoops. One thing that's really funny is you'll note I typed the exit prompt to exit the application. If I relaunch it, if I typo that, it's a prompt. So bid you adieu, farewell. And with that, I'll take a question or two and then pass it over to George.
Does the LLM have access to any data that's in other tables in this database?
Currently, no. I didn't have it quite in time for this demo. I did get a proof of concept, and you know what? I can actually see if I can get that up and running again now. It is possible to use database queries as parts of the prompts. So this is the current system prompt, your helpful agent embodied in a SQL database. I'm going to go ahead and update this. Go away, cursor. So now this is going to use this cursor or the get tools function as a Python F string, and that get tools function is querying our tools table.
Okay.
So I'm going to save this and then go ahead, relaunch this and see if it works. So tell me a joke. Use the joke generator.
And I got that from that.
Code analysis.
And so the converse I had was, can you use the output of the call to the LLM inside like a nest, as a nest, like a nested query, or, you know, your rest of your query would use the output of that as part of.
Yep. So
from,
that is,
you know, where statement.
if I had about 2 to 4 more hours to work on this, that was going to be the next thing. Because you can basically take that and then, you know, that's actually getting saved as the response. So if I go back to query mode, like star from tasks, you'll note that it's in the response here. So I need to like do a migration, add a column to that for like selected tool, probably do some more stuff with state, but that is the next plan, is to change this and be like, all right, do this, join the actual full description from the tool, and then use that. And that way you can basically use the database to store your prompt library or other functions.
So many schemas have reference data
Mhm.
publicly pulled in and put in there, that if you could go use your LLM to get the reference data, maybe it's not efficient, but if it's updating frequently and you don't want to have some ETL process to constantly, you can just go get it on the fly.
Yep. But my plan is to use the tool body for this tools table. It's like start from tools. Basically use this as a prompt template. So it can pick a tool that's best to use with the prompt, then take that template from the actual tool table and put it into the prompt, and then actually respond to it that way. So yeah, it's pretty cool stuff there. What's also fun is I haven't hooked it up yet, but LLMs are pretty decent at writing SQL, especially if it's really basic. And so you can actually use that as well. Let's see. I could just look at the cursor code that I have elsewhere, but nope, I have it set up to pick tool. But document search would be great to do that. So it does indeed, and I'm actually using it over somewhere in here. I just forget the exact syntax. Wait, it was. Yep, that sounds about right. Here we go. Type equals table. We've got 2 tables currently, tasks, tools. Tools, tasks, we got our trigger there. So
Was the goal for you to add your query in English and let it write the SQL code for you, or that's not functionality?
So that's not currently functionality, but I think we will be able to get it to that point, especially for simpler stuff. So.
And I like that everything is in like SQL world where you have functions.
Mhm.
You actually get it moved dynamically by calling take tools from a table and you call them.
Yep. And I will say, I do think that this approach is probably more complicated than it needs to be, and that for a lot of use cases, using something like LlamaIndex or LangChain is likely going to be easier to understand. But thinking about like agentic workflows as things that you could put into a database table, I think is going to be really valuable conceptually.
I've used a variety of tools, and sometimes I just lose my prompt. And so the idea is that before I even do anything, let's save my prompt into the database, and then so that's actually pretty legit. Just thinking about it.
Yep, and I
don't like the
and I do have all of the prompts here that I've put in since the last time I refreshed the database. So I can go back, and if I want, I could then take those and rerun them through a different model, maybe more expensive one, or add characteristics, that kind of thing.
Doesn't get lost just because it failed.
Mhm.
To get that information.
Yep, exactly. Cool. George?
Cool, thank you.
Mhm.
Mine is very short, only 5 minutes, so I know. Can you
hear me? Oh, my slides. I'm just playing an audio video here, just so we can test it. But I can't hear anything. Oh, you want me to change my laptop setting?
Yeah.
Different prompt.
May even have a test button somewhere on there.
It's no output controlled.
Yep, the controls are through here. So that one should be working. Try, can we open up a new browser window?
YouTube.
I was on it. Different one.
Pick something with sound. There's no sound in space.
There is. This is inside the.
Got the captions, so they're talking.
All right, it's fine. It's not worth it. Don't worry. I'll do this. That's fine. So remember this slide, okay? That's what I wanted. Hold that for that 10-second clip. Welcome, everyone. Welcome, Sharks. Make sure I'm on camera. My name is George, and today I'll be preaching to you traveling. We've done this session so many times, so I want to have a little bit of fun here. So I'm looking for 10 minutes in your investment of time in return for 30% increase in your happiness. All right. So Sharks, what is a common problem we all are facing these days?
Well, a lot of work, a lot of come on the Wi-Fi, a lot of Wi-Fi issues. There you go. We're frustrated. Too many things happening, politics and all that, right? Our happiness is taking a hit. Well, we have a solution for you. Our goal is to build a tool that gets to know you better using AI, gets to know you, create a profile, and make you realize your happiness and your dreams. Introducing traveling. So I've used this tool personally, and this is before I use this tool. I'm a big fan of using travel and using, positive energy to travel the world and, achieve happiness and all that. This is me doing a Euro trip in 5 different countries.
Can you share your
Let's see,
screen, please?
Kenya, Greece, Italy, Switzerland, Iceland, and that is 3 a.m. in Iceland, So it took me about a month to do this Euro trip. So how can we get there better, faster, stronger, and cheaper? So how do we explore our dream destinations? Introducing again traveling. So this is an AI automated tool that gets to know you better, right? There's an onboarding process. So we get to know you better. What are your favorite destination types, your countries, your regions, your cities? You like to just chill at the beach, or you want to hike, or you want to be at a camping situation? Do you want to maybe learn
George,
whatever that might be? That's the onboarding process first. So we get to do that.
George, can you share
And
your
this
screen?
AI system gets to recommend your destination based on your history as well as what you currently like to do. We want to do responsible AI here. So we had human in the loop before. We always have human in the loop here, making sure that we get our user confirmation. And then the fun begins. We call all these external tools. We call like hotels, flight, Google Flight APIs, events. Maybe you want to go to Mexico City and do a language immersion program like Robert just came back from. Whatever that might be is there. Yes, I hope so. Dear God. Okay. No, that's fine. I'll record this again with sound. So how does this work under the hood? So this is the layout. I'm not going to go into the code. We look at the code so much, but we have our agents here. We have our base model here. We have our destination vacation. We have our flight deals. We need to onboard the user, so we need to ask them some questions, and then recommend destinations, get their confirmation, look at all the flights and all the hotels that we need to look at, find the best deals, and give them back to them. So these are the different tools we're using here. So I'm not going to look at the code too much. But again, the goal is to go from here where you go log in somewhere online. You have a lot of destinations to explore, right? Based on where you live and where you want to go. Instead of you getting lost in Google Flights and hotels, now we can programmatically look at that, get the data behind it, and give you your destination. So we're starting with flights, but we're going to soon go to hotels and maybe local API if you use local guides, right? When you go somewhere in Google Maps and you say, hey, I like this restaurant, it's great. Or I like this park, it has a great view of the city. That's something that we can add as well. So your happiness await, invite only coming soon. Thank you for joining us. That was my presentation. For real. It's 8:30. Questions? Soon, 2025. I need to get working on it like many other people. Yeah, go ahead. Framework. Yeah, I mean, the code right now is Llama index based, right? As you can see here. Yeah. If you see the libraries, so agent runner tool, we did cover workflows on the last session. So I'm thinking of using workflows as well because there's a loop here, right? You might ask a question, the tool might recommend you something, but you might say, actually, I don't like that. Give me another one. So maybe workflow would be a framework we're going to use.
I missed. Gotta do my homework now.
Workflows, yes. Okay, it's there on YouTube. Yeah, please. It's a really cool and innovative.
Is that a YouTube there?
No, yet, not yet. No, I have to find first where the destination is. Any other questions? Cool. Yeah. So the destination would be you. So let me go here, right? So you'd get your package, basically, your experience, your travel package. So it would be based on your adventure level, how far you want to go, how many things you want to do, and maybe budget and maybe time. So the goal is for this to look at throughout the rest of the year for when is a good time to do this trip, right? Because, for example, if it's summer and you go somewhere where it's really popular, it's going to be, things are going to be crowded, expensive, things like that. So the goal of this tool is to look at like off-season opportunities. Yeah. But it will be a package, like an email, here's a travel destination. Do you agree? Yes or no? Yeah, that's one option. The other option I'm considering is maybe you get a newsletter, right? You sign up, hey, I might be interested in, let's say, Latin America, or I might be interested in Asia or Europe. Once a week, once a month, you get an email saying, hey, there's a great opportunity coming up in 2 weeks from now. Are you interested? And it would do the actual search for you, and then you get all the information. You say, approve, here's my credit card, booked. It's not going to take, it will recommend it for you. You have to say approve or decline. And once you hit approve, it will book everything for you, but you need payment information. Yeah.
Are you actually building this?
I'm building this, yeah.
Is this going to be your?
This is going to be a pet project. Let's see, because the goal is to go here, but faster, right? That's the goal. I mean, I did this awesome Euro trip, so I want to do it again, maybe different countries. I want to tell, hey, I've been to these countries. I like this. Can you recommend something similar? Or I didn't like this. I enjoy trains being always on time in Switzerland. Google Maps said it's going to be late by 1 minute. It was never late. It was always on time. I'm like, okay, I'm going to come back. So yeah, any other questions?
So this is not a commercial, not intended to be commercial.
No, the Shark Tank was just for fun, but no, just building something cool, with the frameworks that we've learned, something that I would use personally, That's how I think of it. Cool. Well, thank you so much. Let me go back to our meetup. Again, on YouTube, you're gonna find us on YouTube. We have a link here. We're gonna upload this. If the Wi-Fi wasn't good, I'm gonna record this and join us again on the next one. We have a session for first week of May at prefect offices. I'm still deciding what the theme should be there, but stay tuned. Yeah, something cool is coming. Cool. Thank you so much for your time. Any questions?